The next part relates to drawing them out. First of all, you draw them out, and the second thing you do is you find out what is the length of it back to the center. These two big lines here, do you see the way there's two big lines encompassing every question, yeah? That means you're looking for distances, okay? It's what's referred to as the modulus. I'll spell that now for you. M-O-D-U-L-U-S. Modulus, okay? So, as an example, the very easy one is the modulus of 3 plus 4i. Okay? What is the modulus of 3 plus 4i? Now, there's two ways of looking at it. The first way requires no new learning, and it works off old stuff you already know. So, the way to do this, one way of doing this is you draw it out on a diagram, 3 across and 4 up. Everybody agree that's 3 plus 4i right there, wouldn't you? The two big lines on the outside, what they mean is this. They want you to find the distance of your complex number back towards the center, 0, 0. So, you could do it two ways. The first way you can do it is you can do the coordinate geometry way we would have learnt last year. On page 18 of your tables, you'll have the distance formula equals x2 minus x1 squared plus y2 minus y1 squared. Always let 0, 0 be x1, y1, and let whatever else you have be x2, y2. Then put them into your distance formula. And what you get is this, guys. You get 3 minus 0 squared plus 4 minus 0 squared. You put that into the calculator. Your answer is 5. So the answer to this question here, your distance is 5. Is everybody alright with that? Okay. Now, we're going to try it again. This time it's going to be, we'll try question 4. Okay, question 4 should be doable. With question 4, guys, what you noticing this time around? It's a bit further away, isn't it? So it's 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And how far down is it? 15 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's a considerably larger modulus than the last question. Would you agree with that? Much longer. Now, what happens here, guys, is once again we have 0, 0. What is our point then? It's minus 8 minus 15i. What point would that be if you're... What point is this then? Minus 8 minus 15. Your x1, y1 value is 0 and 0. Your x2, y2 value? Minus 8 and minus 15. Now, if you're somebody that doesn't want to learn too many formulas, this is the way to go, because you'll always be able to use this formula. Is readily available in the notes in your tables on page 18. So all you have to do is this. You put down minus 8. We're reusing, everybody understands, we're reusing this guy up here, right? So x2 minus x1 minus 8 minus 0 squared, yeah? Plus y2 minus y1. And then it's just going to be wherever that turns out to be in the calculator. It's 64 plus 225. It's going to be 17 to my knowledge. Yeah, it's going to be 17. So you can just put it all in the calculator and you'll get an answer of 17. I'm trusting you can all use the calculator at this stage. Put that in. Now, has anybody noticed something, a way of streamlining this process? What was exactly the same in both questions? What point was exactly the same? The 0, 0 was the same both times, wasn't it? Is there any need to put in 0? No. So a streamlined way of thinking about this would be to do this. Your modulus equals whatever the real value is squared plus whatever the imaginary value is squared. So you don't have to use the distance formula. There's a quicker way, but the downfall of this way is it's not in your tables. So you will have to learn it off by heart. So what I'm saying is here, imagine this question again, and I go, that's the real value, that's the imaginary value. Square root minus 8 squared plus minus 15 squared. I didn't have to draw it out. I understood that it's the length, and then you just put straight into the calculator and you get 17. On questions later in the exercise, so I'll talk about questions up here. So if you take a question like question 12 as an example, in question 12 it's slightly more difficult because do you see the squared on the inside? Now the rule is no matter what is on the inside, make sure that it's solved first. Make sure that it looks something like this. So it means whatever is inside the two straight lines, I have to work on this first. Only when I'm finished working on it can I then apply the modulus formula. Does everybody get that? So whatever they give you in between the two straight lines, work that out first, and then when you're done working that out, then find the length. So as an example, question 12. With question 12, we're going to have 3 minus 2i multiplied by 3 minus 2i. You're going to get 9 minus 6i minus another 6i plus 4i squared. 4i squared, as we all know, is minus 4. This is going to give me the answer of 13. Oh, sorry, not 13. 5 minus 12i. Now, once again, you can choose to do this two ways. If you're a visual learner and you're struggling for the concept, you can go 5 blocks across, 12 blocks down. 3, 6, 9, 12. And you can say, look, that's the 0.5 minus 12. I can find the modulus by finding my distance back towards the center. If you're somebody that has this learned off by heart, you'll realize that it's the real part squared plus the imaginary part squared. And what's the real part squared plus the imaginary part squared this time? Sorry? 5 squared plus minus 12 squared, and that will give you an answer of 13. Your modulus is 13. So, the modulus formula for this one, guys, is this. Modulus formula, whatever it is, it's the real part squared plus the imaginary part squared, and you square root it. Now, imagine that we didn't even know this part, okay? Imagine that this part of the question didn't exist, and I asked you to calculate Z1 over Z2. What was my golden rule? Whatever occurs in between the two straight lines, you do that first. You fix it so that it looks like a standard answer. Then, and only then, Sam, do you do the modulus. Will everybody remember that? Okay, so it's a bit fancier this time. It goes get Z1 over Z2. All it's asked me to do is just put in Z1 is 1 over 7i, Z2 is 4 plus 3i. We're all very familiar that there's a problem here because of the fraction having an I in it. To fix that, what do we do? How do you get rid of the fraction on the bottom? Okay, top and bottom. All you have to do is be really careful with your multiplying, okay? 4 times 1, 4. 1 times 3i, 3i. 7i times 4, 28i. 7i times minus 3i is minus 21i squared. Minus 21i squared is the same thing as plus 21. All on the bottom. 4 times 4, 16. 4 times 3i minus 12i. 3i times 4 plus 12i. 3i times minus 3i minus 9i squared, which is the same thing as plus 9. Now, get rid of that there. Now, just going to work it back this way. 4 plus 21, 25. 28 minus 3, 25. 16 plus 9, 25. 25 divided by 25, 1. 25i divided by 25, 1i. Now and only now can I get the modulus. Okay? So, I'm getting the modulus of this number here. What is the real part? Real part is 1. What's the imaginary part? It's never I, it's the number that comes in front of the I. 1. How do I get the modulus of this answer then? Square root of 1 squared plus 1 squared, which equals square root of 2. And if I take this back, you can see that the answer for a plus bi is just 1 plus 1i. They're both 1s, and the modulus is root 2. Okay, guys.